Okay, so we'll begin with the next talk, the last talk about GStreamer. This time we'll focus on debugging GStreamer applications. A talk by Guillaume Desmottes.
Thank you. So my name is Guillaume. Is that okay for the microphone? Okay. I'm a multimedia engineer working at Collabora. Just to let you know, we are currently looking to hire a bunch of people. So if you're interested working in free software, please let us know. You can find us with this kind of hoodie, and we have a standard job corner. Like that? Okay, come so? Okay. So yeah, if you're interested working on free software with us, just come talk to us. Today I'm going to talk about debugging GStreamer application, what we developed in the last release to make that easier for you, and what I learned while doing that. So I'll start talking about tracers, which are a new mechanism used for debugging. I'll give some more detail on the leak tracer, which I developed a few months ago. I'll talk about GST Shark, and I'll finish with some tools which can help you dealing with GStreamer logs, which I found quite useful. So, GST Tracer, it's a new mechanism which has been introduced in 1.8. It's meant to be used by a debugging tool, so that's the only purpose of this new system. And it allows tracers to hook inside the internal of GStreamer core. So by doing that, plugins can gather a whole lot of information about what's going on in the pipeline. For example, when a buffer is being pushed from one element to another, when all this kind of information. This allows tracers to gather all this info and produce a formatted output. So it's meant to be usable by external application for easily parsing and this kind of things. So it's been proved very useful so far. And now I'm going to show you different kind of things we can do using tracers. Okay, this is absolutely not readable. So yeah, I wasn't sure about the best way to display console output. I tried the image, but apparently that was a terrible idea. To enable tracer, it's pretty easy. You have the GST tracer environment variable that you can just define with the tracers you want to enable. So for this example, I use the stat and the air usage one. So you just define that. And then you launch your GStreamer application. Here I'm using GST Launch, which is the kind of tool we use to test pipeline. But you can do that with pretty much, well, pretty any GStreamer application. So you could use GST Play just to play a video. You could use Totem or whatever. That will work with any GStreamer application, which is pretty convenient. Then you need to say that you want the tracer output to be generated. So for that, we use the GST debug environment variable with the GST tracer category and log level. And then I drop everything to a file using the GST debug file, sorry, environment variable. So as you can see, there is nothing to be done programmatically. You don't have to rebuild anything. It's all integrated in GStreamer itself, and it will be automatically enabled by using those few environment variables. You run that, it will generate a lot of logs to this file. And then there is the GST stat tool, which is part of GStreamer core as well, which will parse those files and generate a bunch of statistics, which are completely unreadable. But it will give you the number of elements which has been in the pipeline, the number of pads, the number of buffer which has been exchanged across the pipeline, the timing as well. So you can see at what time in your pipeline each element has received its first buffer, which can be useful if you have like a very high startup time in your pipeline. You can see which element took more time than the others to start, these kind of things. So that's the stats tracer. Another one which I quite very useful that Olivier mentioned in his talk is the latency tracer. So the idea is each time a buffer is generated at the source, it will travel to the sink, And this tracer will try to measure how long it took to go from the source to the sink. So this is used in live pipeline. Like typically you are capturing from webcam and you are streaming to the internet, or you are displaying on the screen, and you want the latency to be as low as possible. And this can help you to see how long it took for the buffer to be processed by the pipeline. So once again, to use that, you don't have to recompile anything. You just enable the tracer by using the GST tracer environment variable. Then you launch the pipeline. Here I create a simple pipeline which is capturing from the webcam, which is encoding in H.264, which is decoding, and which is then displayed on the screen using the GL image sync element. And the tracer will, for each buffer, tell you how long it took. So you have that here in the time, which is in nanoseconds, which is not really readable. But you have that displayed on the screen. So you have the information in real time to help you debugging this kind of problem. Another kind of things you can do with tracer is to implement very specific tool. So here I'm going to present the leak tracer, which is a tracer I wrote 1 release ago. So the idea is, most of the time when you are dealing with memory leaks, we are using Valgrind. That's, I guess, most C and C++ developers are used to. It's a very great tool, but the problem is it can be very, very slow. So if you are working on very CPU or memory consuming process, sometimes Valgrind will just make things too slow. It's mostly unusable. Another problem of Valgrind is it may not be available on your platform. So as Olivier said, we are doing a lot of embedded development, which usually have terrible build system and distribution and this kind of things. And it may be a challenge just to get Valgrind running. And finally, you may find a lot of memory leak or false positive, but which appear as memory leak to Valgrind, which are totally not related to your code. So if there is a leak in library you are using, like the encoding or decoding library or invalid memory or things like that, you will get all this output from Valgrind, but that's not really something you can easily fix. So most of the time what you really want is to know the leak in the code you actually wrote. So for that, I developed the leak tracer, which is using the new memory, the new system hooks in GStreamer core, and which will manually track the ref counting of each G object and the GST mini object. So that means that only the GStreamer code will be tracked, which is actually what we want here. So it will keep track of that, and at the end of the execution of the application, if it detects that some objects are still alive, so which have been leaked because they should have been destroyed at this point, it will raise a glib running. So that's something you can really hook in your QA system or CI system, and to detect if any leaks has been introduced. This tracer has been integrated in GStreamer core in 1.10. So that means that if you have this GStreamer version, it's already there. You don't have to build any extra tool to use it. So here is an example. Once again, it's the same system. I just use the tracer's environment variable. The tracer is called leak. That's the name I put there. And I run a pipeline. The pipeline needs to terminate because the leaks are detected at the end of the process. So if the process keeps running, obviously we won't be able to know if there is a leak or not. So that's why I say I just want 10 buffers from the source, so the webcam here, and then terminate it. And if at the end of the pipeline it detects a leak, you see, well, it's yellow, so it's warning. You can trust me on that. And it will say, okay, this object is still alive. It will give you what's the type of the object, and it will give you the ref count, so you can have an idea how many references are getting lost in your code. So that's for the basic feature. I try to make it more useful and a bit more smarter. So we are using lip unwind to get a stack trace. So once you enable that, you have to enable it manually because it can consume quite a bunch of memory. So we try to only enable it when we actually need it, and we filter out the object we are interested in. So a typical workflow for that will be to start with the simple version, try to see which object has been leaked. It's really a shame that we can see the name. But you see, okay, the test sync is getting leaked. I'm going to track it down, and then you enable the stack trace for this very specific object. So only this one will be tracked. And when doing that, the tracer output will give you a full call trace. So you can see the succession of calls which leads to the creation of the object. Of course, we don't know where it's been leaked, but at least you know where the object has been created. So if a lot of objects are created in a different context, you can have a better idea of where this object is coming from and start to track down manually the steps leading to the leak. The tracer also produces a bunch of extra features which can be quite useful while debugging. You can track each individual reffing and unreffing operation. So that may be part of the debugging of a specific leak. You'll see each time an object gain or lose a reference, you will see the full stack trace. So that can make things easier for you. You can also enable things like signal support. So if you enable that, you need an extra environment variable. But if you do, you can send the SIG-user1 signal to the process, and that will list all the objects which are currently alive. So this can be useful if you are debugging a problem without terminating the process. And we also have a checkpoint system. So the idea here is you send the signal once to the process. You do something with the application, like, I don't know, start a video and stop it or something like that. And then you send it again, and it will list all the objects which have been created since the last time you received the signal, and all the objects which has been deleted. So this may be useful to develop application that you don't want to start and stop all the time, which will be too complicated to do so. So that's the kind of features we have which you wouldn't find with tools like Valgrind, for example. A few extra tracers. So now I'm going back to the tracers. All the tracers I presented so far are merged in GStreamer core, but third party can also develop their own tracers. GST Shark is one of them. It's developed by Valgrind, and it contains a whole lot of tracers which are more specialized version of the upstream one or provide extra features. You can measure things like inter-latency. So it's a bit like the latency tracer I presented before, except that it will measure the latency between each element in the pipeline, while the upstream one, it's measuring from the source to the sink. So it's a bit more precise on this regard. We have some plan with Nicolas to merge that in the upstream tracer at some point. It can also be used to measure performance on the pipeline, which is something that I found quite useful. So for example, it can give you at what rate our buffer are arriving on each source path in the pipeline. So for example, if you have a pipeline which is not going as fast as it should, so you are expecting 60 FPS in your screen, but you are just getting 20, for example, this may help you to find which element is operating slower. So, and then try to improve the performance on this specific element. It do a lot of different things like schedule times. That's the last time since a buffer has been received on an element, these kind of things. You can use it to track queue. So it's a whole lot of tracers which can be used to track performance and these kind of things. And another nice thing with GST Shark, it comes up with some script to generate graphics using GNU plot from the data generated by the tracers. So you can see things like, so here we have the time, okay, in seconds. Here we have all the elements. So the source, the encoder, the decoder, the things, these kind of things. And here on the left, it will tell you at which rate each element is operating. And here you have the CPU load. And so you can try to see how this is affecting the whole pipeline. So if you see a big spike somewhere, you may ask yourself, okay, this is not something that should happen on my pipeline, and start debugging from there. So that's the kind of things you can do to try to have a bigger picture view of what's happening in your application, which can be quite useful. The last thing I wanted to talk today is some tools to help you working with GStreamer logs. So if you have already done some GStreamer debugging in your life, you probably end up with tons of this kind of logs, which contain a lot of very, very useful information, but which can be quite scary to look at. I know that when I started working with GStreamer, that's something which I was really afraid of that, because you know that this contains helpful information to help you debugging your problem, but you don't really know where to start, you don't really know where to look if you are not used to do that. So I'm going to show you a couple of things which can make that easier for you. A nice one is the GStreamer Debug Viewer, which is a nice Python graphical application, which is part of the GStreamer developer tools set. So that's something you can find on the GStreamer Git repository, and which will parse the full log and will give you a graphical interface to look at that. So you see here on the top bar, it will some kind of graph over time of when the logs are being generated, because each log is associated with a timestamp. So we can see at the beginning of the at the start of the application, a lot of logs are being generated, then some gap, then some log. Then here we have a very big gap between more activity occurs in the pipeline. So just by looking at that, you can see that there is a gap here. So you may ask yourself, why is my pipeline blocked at this point? Because usually when a pipeline is doing something, it produces some log. And just try to look at what's going on here. So for example, am I waiting for the kernel, or is a thread block, or something like that? So that's a nice tool you can use to do that. And another one I just started a few months ago is GST log parser. My goal here was I often find myself writing small Python application to parse logs. So for example, if I wanted to compute some metrics from specific logs of these kind of things, and I was always doing very hacky Python script to do that. And I say, okay, let's try if I can do something more reusable and a bit cleaner. It was also a time where I wanted to learn Rust. So I said, okay, let's try to write it in Rust. This is literally my first Rust project. So the code may not be so well written, but at least it's been proved useful so far. So it's a high-level parsing library which will read your log and create high-level object for them. It will give you an iterator in Rust, and from that you can very easily filter for a specific category, from a specific object, specific line or whatever, and do some basically whatever you want with that. So the code is there on GitHub, and I will just give you one small example of things you can really easily do. Is once again it's not readable, but tsdiff is a small tool I wrote using that, and which will for each thread will compute the difference between one specific event and the last event is this thread. So once again, if there is some point a gap in the pipeline which is being stuck, it will detect it very easily. And it's not yet not really readable, but the bigger difference will be highlighted in red. So just by parsing that, you can see, okay, my pipeline here rated for 100 milliseconds. That shouldn't happen. What's going on here? So just you can see the timestamp difference very easily using that. And that's it. I think I have like 25 seconds for questions.
5 minutes, actually.
Ah, okay, it's not enough. Ah, okay, great. Okay.
On change. Si je prends ça, j'arrive. J'ai vu des questions là-bas. Levez la main parce que oui. Bon, je vais commencer par le plus simple.
Hello.
Hi.
So when you mentioned in the beginning the leak tracer, you're right, Valgrind is very slow for most things, but there is also Libasan, which is much faster. But can you, if you want, if someone wants to use Libasan, can you use it with your GST tracer, leak tracer, or is it?
So is the LLVM tool?
No, Libasan is actually part of. It's included in the GCC.
Okay, I don't think
So
I
it's
ever
an
worked with that.
address sanitizer, basically. So it's much faster.
Ah, okay.
You can. It does not. The difference is that it does not detect the origins of the leaks, but it finds the leaks.
Okay,
It also
I know.
produces stack trace.
Okay, I never tried using it. It's good to know. Thank you.
Okay.
Yeah, I guess it will be more.
It's more generic.
Yeah, more generic and
Yeah.
lower level kind of tool like Valgrind. So yeah,
Yeah. Okay.
and the ref counting. Yeah, it won't do ref counting. Yeah. So it's a bit like with Valgrind. It will just find the memory leak. While here we are interested in ref counting problems. So the leak tracer will be like a more specialized tool for a very specific problem. And I guess Libasan could be more like a replacement to Valgrind, I guess.
Okay. Thanks.
Oh, you do?
Thanks.
Ah, maybe that's why I wasn't looking at that. Yes. Apparently you have to recompile to be able to use it?
Yes.
Ah, okay. Ah, yeah. Okay. I remember I looked at that a while ago, and that was a problem for me because I was working on embedded device, and recompiling with specific tool can be quite challenging, which is why I went to the tracer approach. Yeah.
So it can work without any other kind. You just enable.
Yeah, exactly. Yes. Yeah. If you build a recent version of GStreamer, it should be built by default, and it will work. The only thing you may want to change for a build system is to make sure to have lib unwind, which will allow you to get the stack trace. But even if you don't, it has some fallback code which will try to get you useful information. So yeah, that's the big advantage of the tracer, I think, is you don't need to rebuild anything. Anything else? Yeah.
You mentioned the GST Shark.
Yes.
How do you use it? Is it an element in the pipeline, or is it a standalone?
No. It's a set of tools. So it's a bunch of tracers. So it's a GStreamer plugin basically.
Yeah.
And but it's not part of GStreamer core. So you will have to build it yourself manually, and it will give you all the tracer I mentioned to get more information about the performance, about the interlatency, and the script to generate the graph I show as well. So it's not an element, it's a bunch of tracer and scripts to produce useful information from that. Anyone else? Nope. Okay, thank you very much.
We have a question in the back.
Wait for the microphone for the recorder.
Hi, I used to have some pixelization issues when I'm trying to play the encrypted dash streams.
Mm-hmm.
So which is the best efficient method of debugging those kind of pixelization issues?
Well, what I will do, I will start by looking at the logs from the specific element which will cause the problem.
Mostly the GST launch is completely successful, and I did not see any error logs.
Yeah, that's why you have to use the GST debug environment variable I mentioned here.
Yeah.
So if you use, where is it? GST debug here. So here I ask him to just give me the information about the tracer, but if you put just 5, for example, that will give you all the debug information of all the elements, which will be quite a lot.
Okay.
But from there, you can start looking at what's going on, and that will give you more information. After that, you'll have to end up debugging. So if you are not used to do that yourself, the best way would be to just file a bug, I'd say. And
Great,
maybe,
thanks.
Yeah. There is no magic answer, unfortunately. Debugging is art, and I'm afraid it will always be. Anything else? Okay,
Or
I
last
think the time is up.
question, maybe?
Time is up. Okay. Thank you very much.
Okay. Thank you.